multiplication and how to make approximations or estimations. We'll investigate two strategies. We'll look at finding a lower bound and an upper bound, which is just a fancy way of saying you're going to make an estimate that you know is too low and an estimate that you know is too high, and then your real answer will fall somewhere in between. And then we'll also look at simply rounding each factor to get an approximate answer. In our first method, we're going to start by finding an estimate that we know is too low. We'll call this the lower bound when we can consider it the floor. We'll always know that our exact answer is above this number. I've represented the product of 1 3/10 and 2 89/100 with an area model. If we think of this as length and width, we know here that I have defined my little square to be 1/10. So this side will be my 1 3/10, and then the longer side is going to be my 2 89/100. So the exact answer is the shaded area of this region. And what I'm going to do is I'm going to reduce one or both of these numbers to make the shaded area smaller. It'll be too low of an estimate. So I could just look at the ones place only and chop off the remaining digits and say, well, I'm going to estimate this area as 1 by 2. So that would be cutting off my 1.3, cutting off my 2.89. But this is quite an underestimate. There's a lot of area that has been excluded, so I know I can do better. What I'm going to do is say, well, 1 is a great number because I can multiply anything by 1 easily in my head. And I'm going to go ahead and keep the second number as 2 89/100. There's no need to cut it off when I can just multiply by 1. So 1 by 2 89/100. Now I've left off this area, but I knew all along this was going to be an underestimate. So I can use 1 and 2 89/100. There isn't a right answer here, guys. We can do any number. The key is to pick numbers you can multiply in your head. If you're going to do an estimate, you want to do it quickly in your head and not have to do a long computation. So we're just looking for easy numbers to multiply, but the closer the reduced values are to the original values, the better the estimate. So when I only decreased the 1.3, I got a better estimate. So that's my lower bound, 2 89/100. And then now I'm going to look at an upper bound. So again, I have my 1 3/10, my 2 89/100. And now the idea is I'm going to draw a rectangle that's bigger than this one, which means I'll have too much area. It'll be an overestimate. So I could increase each of these in the ones place and make this 2 by 3. 2 doesn't even fit on my picture here. 3, that's going to be a huge overestimate. Look at all that extra area that I have there for a 2 by 3. So I can do a little bit better here. And I think about, what can I do in my head? Well, if I kept the 3 and 1 3/10, I can do that one in my head. That's just going to be 3 9/10. What does that look like? That's keeping the 1 3/10, and that's increasing the 2 89/100 up to 3. And that is a pretty good estimate. I only have a little bit that I went over. So this was 1.3 by 3. So we know that our answer will be less than 3 9/10. So our upper bound was 3 9/10. That came from 1.3 times 3. And our lower bound was 2 89/100. That came from 1 times 2 89/100. And so we know that our exact answer is going to fall between the lower bound and the upper bound. So our floor is less than the exact answer, which is less than the ceiling. Check out our exact answer. Indeed, it does fall in between our two numbers. So this was a good bound. Our next method involves just rounding the numbers and multiplying them. So here I might choose to round to the nearest ones place. Then I would have 1 times 3. So I would say 3, my product is approximately 3. Again, I could choose to only round one of the numbers. I could make this 1 times 2 and 69 hundredths, 2.69. These are both approximates. So this method is a little bit faster, maybe a little easier. The disadvantage is if I round one number down and another number up, I have no idea if this is going to be over or under my exact value. Remember, this was my exact value, but since